Hi, welcome to another Observatory Online. Now this time I want to highlight a very popular astronomical object, the Orion Nebula. At the moment it's low on the horizon by the time the sun goes down, and here in the UK it's not going to be up at night for very much longer, so this is a sort of last chance to see before it returns in the winter skies. Okay, here we go. Over towards the southwest, as the sun sets, we can see the stars of the constellation Orion. There he is. Or, there he is. Actually, we're interested in his sword. That's the nebula. With the naked eye, you'll be able to see a small cluster of a few stars, and with good binoculars, or a small telescope, a fuzzy patch. Let me show you what Hubble sees. It's pretty nice, right? Now obviously this image is from a space telescope, and it's very heavily processed. But the Orion Nebula is still worth trying to see yourself. And honestly, have a search online for some of the amazing amateur images that people are producing. It's really special stuff. You'll get an understanding that it has an angular size. It's not a little point of light like a star, but it's hinting at the vast structure that you're looking at. What we're seeing is a stellar nursery more than 1,300 light years away. Vast clouds of gas are collapsing under gravity, giving birth to stars. Our own sun would have been born in a similar nursery. But the processes actually destroy the nursery. We can point to the first homes of other stars, but not our own. In fact, Hubble can actually see these protostellar systems called proplyds. Proplyds? Well, let's not argue. Look at these cute little baby star systems.
Hi, I'm Emily, an astronomer at the Royal Observatory, and today I wanted to talk about how rocky planets form. Now, these are planets like the Earth, but also include planets like Mercury, Venus, and Mars. Now, to understand how a rocky planet forms, we need to understand some of the smallest things in our universe, what I like to think of as stardust. Now, dust in space is not the same kind of dust that you have in your homes here on the Earth. Stardust is more similar to smoke, and it's made up of tiny grains of silicon, carbon, or iron that are combined with oxygen to form minerals. Now, this is what a dust grain looks like from space. It's incredibly small. It's 10 to 50 times smaller than the width of a human hair. This dust is literally stardust. It formed inside of the bellies of stars that exploded and scattered the dust throughout our universe. The dust in our own galaxy can be found in nebulae. These nebulae are filled with dust and gas and are the places where stars form. So, how does a rocky planet form around a star? Now, we think that over time, these tiny dust grains will stick together. They start to form into small, centimeter-sized rocks or pebbles, a little bit smaller than the meteorite I'm holding now. Now, eventually these small pebbles will stick together and form bigger rocks, and they will keep growing until we have something that's the size of a rocky planet, so hundreds of kilometers in size. As the planet builds up over time, the pressure in the core increases, and that also increases the temperature. That causes the materials to melt together and separate. Now, this process takes millions of years, and there are still many questions for us astronomers to answer. But by recreating the conditions of space in a laboratory, studying meteorites that came from space, like this meteorite, and using telescopes to observe young planets as they form, we can get a better idea about how rocky planets form.
When we look up at the sky, it's easy to feel like the stars are close, so close we can almost touch them, but we know that's not quite the case. We know that everything in space is actually really far apart. In fact, so far apart that you might say the distances involved are astronomical. My name is Bryony, and I am an astronomer at the Royal Observatory Greenwich, and today I'm going to talk a little bit about how far away things are, as well as the strange unit astronomers use called the light year. Now, you might have heard of the light year, and you might think that it's a unit of time. After all, it has the word year in it. But that's not the case. The light year is a unit of distance. Now, the light year is the distance that light travels in 1 year. Now, light travels pretty fast. In fact, it is the fastest thing in the entire universe, the speed limit, if you will. And because of that, it travels about 9.5 trillion kilometers every year. It's pretty fast. And you might think that's a ridiculous amount. That's ridiculous. Why do we ever need anything so huge? Well, our next nearest star, apart from our sun, Proxima Centauri, is over 4 light years away. And everything else in the sky is even further than that. Now, some really common things you might have seen in the sky. I'm going to tell you just how far away they are in light years. For example, Polaris, the North Star. Now, the North Star is somewhere between 350 and 450 light years away from us. And what that means is that it takes light 350 to 450 years to get to us. And this is the case for everything in the sky. It always takes that long for the light to get to us. And so what this means is that we are always seeing everything as it was in the past. Everything we see up in the sky, we're seeing as it was years, decades, even centuries ago. Really, being an astronomer in some ways is almost like being a historian. We just get prettier pictures.
Stuff. There's quite a lot of it out there. In physics, we call this stuff matter. And you, your food, your house, the planet Earth, even the stars up in the sky are all made out of it. And yet, as far as the universe is concerned, that appears to be the tip of the iceberg. I'm Dr. Greg Brown, one of the astronomers at the Royal Observatory, Greenwich, and today I'm going to be talking about the matter of matter, specifically dark matter. You see, when astronomers studied distant galaxies, they noticed something a bit weird. Galaxies spin, a bit like our own planet Earth does, but how fast they spin is dependent on how much mass they have. The more stuff you have crammed in a galaxy, the stronger its gravitational pull, so it can hold on to fast-moving stars in distant parts of the galaxy without them flying out into deep space. And yet, if you look at a galaxy and compare how much stuff you can actually see to how much stuff the galaxy should have, you come up short. Like really short. So what's going on? Well, one possibility is that our entire understanding of gravity is completely and utterly wrong. Which is possible, and we are checking, but it seems unlikely. Another possibility is that there's something else out there called dark matter. It's like normal matter, except it's invisible and undetectable, and it passes through normal matter without you even noticing. But it does have mass, and so it has gravity, and so could solve our problem. Thing is, if our sums are correct, it outweighs normal matter 5 to 1. And we can't find it, which is a bit embarrassing. But it could be worse. You see, we may not understand much about dark matter, but we understand even less about dark energy, which doesn't matter right now.
Hi, I'm Emily, an astronomer at the Royal Observatory, and I'll be talking about our closest neighbor in space, the Moon, the phases of the Moon, and why the moon phase tonight is special. Now, the Moon is orbiting the Earth. The reason why we can see the Moon is because light from the Sun is reflecting off of its surface. Without the Sun, we wouldn't be able to see the Moon. Now, there also wouldn't be any life on Earth without the Sun because it would be incredibly cold and dark, but that's a topic for another day. The phases of the Moon depend on where the Moon is in its orbit. Sometimes we can't see the Moon at all, and this is what we call a new moon. It is when the Sun, Moon, and Earth line up, and the side of the Moon we can see from the Earth is completely in shadow. As the Moon orbits the Earth, more and more sunlight will move across the surface of the Moon. That makes it look like the Moon is getting larger, and these are what we call waxing phases. The full moon is when the Moon is on the opposite side of the Earth as the Sun, and then the Moon will continue in its orbit. Shadow will start to move across the surface of the Moon, and so the Moon looks like it's getting smaller. These are called waning phases. Eventually, we won't be able to see the Moon at all again, so we're back to a new moon. Now, to go through all of the Moon phases, that takes 29.5 days, so nearly a calendar month. A month sounds a bit like a month, so it kind of makes sense. So, why is tonight so special? The new moon was on April 23rd. This is when we couldn't see the Moon. Tonight will be the first time we can see the Moon after a new moon, and we call this the new Crescent Moon. The new Crescent Moon is particularly important for individuals who use lunar calendars, like the one used in Islam. This particular new crescent moon will mark the start of Ramadan for many Muslims around the world.
When Pluto was first discovered back in 1930, it was called the ninth planet of the solar system. But in 2006, that changed when it was reclassified to be known as a dwarf planet. Why was that? My name is Anna and I'm one of the astronomers from the Royal Observatory in Greenwich, and today I'm going to be talking to you about how we classify objects in space. There are lots of different objects out in our solar system and we're discovering more all the time, but when we find something new, how do we decide what it is? Well, the most obvious object out there in space to start off with is a planet. And in order for something to be classified as a planet, it needs to follow three specific things. Number one, it needs to orbit around the sun. Number two, it has to be round. Number three, it has to have cleared the neighbourhood of its orbit, so not really have any debris, other rocks, things in its way as it makes its path around the sun. Now, Pluto only actually follows two of those three criteria. Yes, it does orbit around the sun. Yes, it is big enough to have made itself into a spherical shape, but it doesn't have a clear orbit. It's out in a part of the solar system known as the Kuiper Belt that has lots of other objects there. So because Pluto only follows two of those criteria, it is put into that category of dwarf planets. To be a dwarf planet, you have to follow point number one, you have to orbit around the sun, and only follow one of the other 2 points. There are actually 5 official dwarf planets in our solar system at the moment, so Pluto isn't alone in that category. These categories were introduced by the International Astronomical Union in 2006, so that is why that is the year that Pluto changed its classification from planet to dwarf planet.